Hello, everyone. I think we're currently live, so let's take a couple of minutes so everyone would tune in. And as you know, now you're at Zaka's Live, and we have an interesting talk today. So feel free to introduce yourself in the chat. Tell us more where you're tuning in from. I'm personally tuning in from Lebanon currently. And I think our two speakers, Ahmed and Shadi, are tuning in from Cairo. Let us know if this is correct.
Yes, we're from Cairo.
Great.
We're in different parts of town. We're in actually opposite part of town. So I'm in West Cairo. He's in East Cairo. So just to, if this is interesting to anyone.
Cool. So let us know if anyone is joining also from Cairo. We have Hisham, welcome, Raed, Nada. So introduce yourself. Tell us know where you're tuning in from, and we'll be starting in a few just to ensure that everyone joined and that the meeting. Let us know also if you can see us clearly and you can hear us clearly. So if you still didn't subscribe to our newsletter, at Zaka, we always push AI education in the MENA region. So subscribe to our newsletter at zaka.ai, and you will be the first to know about our upcoming webinars and talks. And you can also suggest any maybe future talk that you would like to know more about it. So hi Mu'tasim, hi Sarah, hi Hiba from Qatar, hi Nada, hi Sarah again, another Sarah. So, and also if you're tuning in now from YouTube or LinkedIn, this session is interactive. Our speakers are really interested to know more about you, to understand more, maybe your questions, to really support you in your ML and production if you want journey. And the title of the talk, as you know, is How to Deploy and Manage Machine Learning in Production. So we have with us Ahmed. He founded Synapse Analytics back in 2019. And a small introduction about the company. It's specialized in helping companies to adopt AI in their operation, customer experience, and to build innovative business models using their data. And we also have Shadi. He's also the CTO of Synapse Analytics. And he will be also walking you through the main concepts of MLOPs and the feature of this problem. So if you now maybe have some questions and you want to know more about them, just drop them. I'm pretty sure they will answer them. And I'll leave the floor to Ahmed to start maybe introducing the talk or maybe the company also and add anything about it. Just one thing, if you didn't read the resources that they sent, I'll drop them again in the chat. Make sure after the talk to read them. They sent some useful, if you want, links and blogs about explaining maybe the difference between DevOps and MLOps and the journey into ML into production. I'll drop them in the chat. The floor is yours, Ahmed.
Thank you, Larissa, and welcome everyone. We're very, very excited to be with you today, especially that we know that most of the students from the Zaka students are actually graduating and pitching their capstone projects next week. So this is really exciting, and I'm sure you guys have been working on some really interesting things in the past few months, and I hope that this talk would be as relevant as possible to your work. And so please, as we're going through the talk and the platform, please drop in your questions as much as you can. Let's try to make this more of a two-way thing rather than just us telling you about our experience and our how we deploy and scale machine learning. Please let us know your questions. Please let us know what you're really curious about, what you're really excited about in either uplifting your career in AI or maybe you're starting your career in AI. What's most exciting about that to you, and what are you really looking for in the market? So that said, let me tell you a little bit about Shadi and myself. So we're basically Synapse Analytics. We are a data science and AI company based in Cairo, Egypt, and we've been working. We've started, as Larissa said, in 2018. We have managed more than 30 deployments. 15 of them are actually active on the platform that we're actually going to show you today. And we've seen, like we always say that Konan came out of the dirt. So Konan came out of Konan, which is the MLOps platform that we'll show you today. It really came out of our suffering. We helped a lot of companies to build their AIs, and we saw the major problems they face when they deploy, because we were the ones who were actually deploying the AI and deploying the machine learning algorithms that we spent so much time and effort and sweat trying to build them and get them to production. So all of these problems we've seen, and they became very, very repetitive, that we decided to do something about it. And this is where Konan came about. So I usually, they say that anything is useful when it is being used. And it's also true about ML. So if you build the best algorithm in the world, if you build the best AI in the world, and it's not used, it's not adopted, usually this is not useful for anyone. Although you might have spent a lot of time, tinkering with the parameters, trying to uplift the accuracy as much as you can, playing with the data, doing everything that is normal in the data science cycle or the machine learning building cycle, and then you come to deployment and you're unable to deploy. This is very frustrating to you as a data scientist or as a machine learning engineer, and this creates some sort of a lack of trust between the business or your customer and yourself, because at the end of the day you came to them and you told them that you'll build them the AI that will get them to the next level, to the new age of doing business and taking decisions, and then the AI is nowhere to be found. So this is why being able to deploy, manage, and scale production grade AI or production grade machine learning is really a great differentiator for any data scientist in the market. So that said, let me tell you about some of the problems that usually arise from getting to deploy your machine learning or getting to deploy your AI in production. So one major problem in many companies is that the data scientist usually is responsible for building the model, and often the data scientist does not come from an engineering or software engineering background. So sometimes they can be brilliant at creating these incredible models, but they have really a lot of difficulty. They face a lot of difficulty in bringing the AI into production, or doing the necessary integrations, building the data pipelines necessary to be able to deploy their AI. So what happens? Usually they go to the software engineering team. So if you're working in one of the big companies, or you're working with a company that have like big data or big technical teams, usually you have a data science department and a software engineering department that is responsible for application releases, all the integrations and so forth. So the data scientist has spent, for example, 3 months building their algorithm, and they're very happy with it, and they come, running to the software engineering, maybe skipping a step and doing the happy hops while they're going to the software engineering department, and then they tell the software engineer, please, this is the AI, please get it into production. And now the software engineer is looking back at them, and he's really, the software engineer having this huge backlog of things that they have to do, or she has to do, and they didn't want really another task on their hand. So this is one of the things that sometimes can delay deployments. And once we talked with a customer, and the customer actually told us that it takes them 8 months just to deploy AI. And now we found a very interesting statistic. It was published by VentureBeat, and the statistic was that 87% of ML models never make it to production. And this is incredible. So you think, as a data scientist, you've spent all of this time tweaking and preparing the data, building the models, validating the models, testing the models, and then you come to deployment, and the algorithm never never sees the light of day. So this is, of course, very disengaging to you as a data scientist, and because this is actually a very new and emerging technology to most companies, to most technology teams, because AI and machine learning used to be was in like research mode, very very and it came out to the market um, uh, very recently. So usually most businesses and most people who want to deploy AI are still really trying to figure out what is the best workflow to be able to deploy these models. And this is why you can see that 87% of ML models never make it to production. Now, what happens now if you were successful to put it to production? Another set of problems arise from that. And one of the main problems that actually happen within a business or within any context that is adopting machine learning, usually a really interesting diffusion of responsibility happens after the ML is into production. And because who really owns the AI after it's being deployed? So let's say for example, the AI did a wrong prediction. Let's imagine a credit scoring model by which basically the AI predicts the risk of a certain customer paying back a certain loan, a certain financial facility of any sort. So now the customer, if the AI predicts wrong and the customer did not pay back the loan or the financial facility, who is responsible for it? Is it the data scientists who built the model and who validated the model and who told everyone that this model is perfect and you can put it into production and it will provide you with the best risk assessment possible? Or is it the software engineer who maybe did not actually serve the right data to the machine learning model? So for example, if you're a data scientist and you trained on a data set, and now when in production, the model receives a completely different data set or a completely different variable, for example. So if you have, for example, 10 variables, one of them is not does not match the distribution as in training, for example. So the model didn't actually get the right data to be able to provide the right prediction. So who is responsible for that? Is it the software engineer, or is it the business, the credit officer who supposedly who has the business intuition to be able to criticize and say that this person should not have gotten the financial facility? So of course this is a real problem that happens in almost every machine learning production or deployment. And now you have to have a certain owner, and usually they don't have an owner for it. So the data scientist says it's the software engineering problem. The software engineering says it's the business problem. And everyone is pointing fingers to each other, and it's really hard to really diagnose the problem and really understand why the prediction is wrong. And this is one of the things that also happens post-production. So these are two example of problems that happens, and they're very, very recurrent, and they're very common amongst many machine learning departments and many machine learning teams. And this is why we have built Konan, the platform that we'll show you today, to be able to give autonomy to the data scientists, to be able to be fully responsible for their deployment, to be able to monitor, to diagnose, to make sure whenever something wrong happens, they are able to diagnose the problem and really fix it really quickly, instead of, for example, taking it out of production and then trying to fix it for a period, for example, of 6 weeks, and then reinstalling it into production or redeploying it into production. And now the business has lost, in these 6 weeks, for example, the business has lost opportunities. The customer experience is bad. The business is losing money with every day the model is not into production. So of course this creates a lot of again disengagement from the business side and from the data scientist and from the whole AI strategy. Usually people might label it as a failure, though it's not really. It didn't really get a chance to realize its potential. So this is why Konan exists. Now today in the talk will be divided into two main chapters. So the first chapter, my colleague and my partner in crime, Shadi Fanous, will take you through the traditional model or the traditional way of putting models into production and thinking about models in production, and then we'll take you through how to do it in a manner that increases significantly the probability of success, and make you as a data scientist and make you as a machine learning engineer really capable of fulfilling your promises, of really changing the business field that you're working with. Because at the end of the day, AI is a very, very powerful tool and a very powerful technology, and I can tell you that from experience. And if we have time, we can talk a little bit about some of the use cases. But AI is a very powerful technology, and it's really a big shame when a brilliant data scientist is unable to really prove how powerful the tool and the knowledge they have to realize its potential and to actually really do the transformation necessary. So that said, Shadi, please take us through the machine learning cycle and how MLOps is how to create a sustainable MLOps workflow and how to scale our deployments. I hope you guys are excited. And please, as I said, please, drop these questions. Don't hesitate, and let this be more of a two-way thing rather than just us showing you the, how we do it and so on. Shadi, you have the floor.
Sure. Thank you, Ahmed, for the wonderful introduction. Like Ahmed said, guys, if you have any questions, feel free to drop them down. We're gonna have a small Q&A session at the end to answer them. So I think let's dive right in. I'm not sure. Yeah, let's dive right into the slides. So first things first, let's talk about the machine learning lifecycle. So essentially, as a data scientist, what we at Synapse we like to say is we like to divide the machine learning lifecycle into two parts: the development phase and the production phase. What the development phase entails is you need to gather your data, you need to clean it, you need to prepare it, and then you need to do some future engineering depending on the model you're actually going to develop. And then you train, and after you train, you would have to validate that this model actually outputs the good enough accuracy or error metric that you desire. Once that's done, now you have to actually deploy it or productionize it, as we like to say. So what that entails is you have to set up the infrastructure required for it. That includes VM, databases, any storage requirements that you need. Of course, after that, you need to actually think about how people would integrate with this model. Are they going to use REST? Are they going to use RPC? Is it going to be a callable script? When is it going to be called? How is it going to be integrated into your infrastructure? And so on. Once it's in your infrastructure, now you have a couple of other tasks as well. How would you go about to monitor this model in terms of either accuracy or metrics, or in terms of the data going in and going out of the model? So this is like I'd say a slimmed down version of the machine learning lifecycle. So let's take it piece by piece and discuss it even further. So yeah, as I said, this is how you actually deploy a machine learning model in the old fashion, we'd like to call it. You provision your infrastructure, you create an API surrounding it, you'd containerize your model through something either Docker or Podman or whatever containerization technology you prefer. And you'd actually deploy the model and forget it. This is the old way. Now, the new way, or the reality of it, is you still do the provisioning, the creation of the API, the containerization, and the deployment, but now you have to take into consideration some other stuff that you didn't take into account from the beginning, which includes model monitoring, either through data or through the API, retraining, when would you retrain the model, and so on. So I think, yeah, we have a question. Which deployment model will you introduce, guys? So yeah, we're going to talk about both, either the callable script or the integration using APIs. But what we're going to showcase at the end as what we think is the best is deploying machine learning models as a web service that to be used. We're going to discuss this as well later on in the slides. So I hope this answers your questions, because if not, I think you asked it if I didn't understand correctly. So yeah, let's talk about the pain points of deploying machine learning models. First off, they need additional functionalities when they're being deployed. So that includes monitoring, when are you going to retrain, scaling. If for example, you anticipate that you're going to get a certain amount of traffic throughout the deployment, and suddenly this traffic goes up, your model is probably going to hang. It's going to have a slow response time. So you actually need to be on top of things in terms of scaling your infrastructure to handle the increase of load. The second problem is you're going to have to require a cross-functional team to help you with this deployment. So that includes the data scientist that's actually going to do the model deployment, a DevOps engineer that's going to provision your infrastructure. You're going to need a backend engineer to create the APIs and to create any endpoints that are needed to monitor the metrics. And you're also going to need a front-end engineer that's going to create either the dashboards or the UI or anything else.
And Shady, if I may here to interject, so you can see, guys, how many people. One of the things about machine learning, especially in industry, that it's one of the most multidisciplinary projects that many organizations have ever worked on. So I would add here, Shady, also sometimes you really need like the business input as well, because at the end of the day, the business user is the one who's going to utilize, and maybe you're serving the business, a supply chain manager, for example, or a distribution or logistics manager. So I would add on these roles as well, the business persona as well. And this is why it's so cross-functional. So sometimes, nobody owns the project. And this is where sometimes an organization has to think about really ownership and creating an ML workflow. It's not like traditional application deployment or any of that at all. So this is why it's really important to create the sustainable MLOps flow. Shady, please go ahead. Sorry to interject. I just wanted to.
Can you hear me, or is the mic?
Yeah, we can hear you fine.
Okay, great. Okay. So yeah, but yeah, you have a very valid point. So yeah, let's go to the other slide. Okay, loss of business opportunity. So when you deploy a model and you figure out that, okay, I can't sustain this model in production, people are actually going to lose trust in either the model or the data scientist. So this happens if, I think, like the example Abaza mentioned at the beginning, if you're deploying a credit scoring model and you suddenly realize that it's failing, people are going to lose trust in this technology and the people behind this technology. So this impacts both the business and the people doing it. Another problem is how long the process takes. Because usually data scientists do the model and they hand it off to either back-end or DevOps engineers to complete the rest of the cycle. This handover takes, from our estimate, around 6 weeks. So this is a pretty huge gap between when the model is finalized and when it's deployed into production. So this causes a lot of issues in terms of deadlines or in terms of the business trust. So yeah, it's a big problem.
Can you guys imagine 6 weeks? So if you're, for example, doing a recommendation engine for e-commerce, and if we take the example, there was a statistic that almost 35% of Amazon's revenue come from actually recommendation engines. So can you imagine if we take this recommendation engine off production for 6 weeks and then redeploy it again? So how much money is lost during that time? It's of course a very, very tough problem to have, and it's very, again, I just want to use disengaging because at the beginning, in our experience, especially businesses are super excited about AI and about machine learning at the very first meeting. And then while they see all of this, hassle and obstacles through the deployment and through productizing the AI, usually it's really disengaging to them. They really feel very disappointed about the technology, and they think, maybe the technology doesn't work really well. So this is why, time is of the essence, literally, when it comes to machine learning. Please go ahead, Shady.
Yep. So yeah, the last point is diffusion of responsibility. I think we've covered that in the beginning. Who's responsible for the ML deployment? Is it the data scientist? Is it the ML engineer? Is it the back-end engineer? Or is it a collection of them? So yeah, the diffusion responsibility is actually a big issue. So yeah, in comes MLOps. What MLOps tries to do is it essentially tries to tighten up all these loose ends into a tight cycle, which includes development and deployment and maintenance of machine learning models in production. And this is the reason as well why we created Konan, because from our experience from deploying machine learning models, we've seen the necessity of such a tool, and we've actually concluded that, yeah, we need something. Let's build something that helps us with this based on our experience that we've gained throughout the years. So yeah, let's talk about Konan for a little bit. So yeah, like I said, MLOps consists of three main pillars: deployment, monitoring, and maintenance. So again, I actually might want to emphasize what we're focusing on in Konan is the post-deployment part. We actually believe that data scientists are the best when it comes to the creation of models. So what we're trying to do with Konan is enabling data scientists that already have a very good knowledge base of the creation of models and so on to be able to deploy them seamlessly as well. So yeah, what Konan does is it allows you to deploy any model. It's language and framework agnostic. So if you want to deploy something written in Python, TensorFlow, you can do that. If you want to deploy something written in MATLAB, you can do that as well. We also take off the load of provisioning of infrastructure. If you deploy a model through Konan, it will automatically provisions the necessary infrastructure for you and post the model on it. We also automatically create any API integrations that you need. So for example, we create RESTful documentations that you can give out to your clients or to your either that they're internal or external, so they can easily integrate with the model. Also, we have constant monitoring of what goes in and out of the models. So you have like a table of anyone that did anything using the model. We also have performance monitoring, either that's accuracy or error monitoring, data statistics and drift monitoring. I'm also going to showcase that as well. Auto scaling, we've talked about that. We also have something called challenger models. So for example, if you've deployed a credit scoring model and you want to try out another model, instead of pulling all the data and pushing it to the new model and seeing how it fares, you can actually deploy this model in parallel with the one that's currently running live, and it will get all the inputs and it will give you an aggregate report of how it would have performed if it was live. And finally, we support model retraining. So you can instantaneously say, I want to retrain this model using this data. Let's retrain it and redeploy it. So yeah, I think we could start the demo.
So let me give some shout outs to the audience. I'll try to do it as fast as I can before you start the demo. So hello to Roland, Ahmed Ibrahim, Mu'tasim Yusuf, Nada Baidoun, Christophe, Ahmed Masri, Fatima, Omar, Sarah, Ahmed, Sarah again. So Sarah Hamoud. It's the same Sarah. Hi, Sarah. We have Hazm, who is a data scientist. Peter, Raed, Hiba. We have a lot of very practicing data scientists. So Raed, Hisham, and Restream. I think Restream is the platform we're using. It's not a person, or maybe it is. In the age of AI, you're never so sure. So, guys, please let me know what are your questions So we have a question, and Sondus, hi Sondus, and we have from Roland. So Dr. Roland, if Konan can provision infrastructure, can it do that for all available cloud infrastructure? Shadi, do you want to answer that?
Yeah, what we're going to showcase right now is the SaaS solutions. So we've already handled all the we've handled everything. But yeah, the on-prem, it works on Azure, AWS, GCP. It works on whatever cloud you're working with.
And hi Simon. Hello Simon.
Yes, it does that automatically. Yes.
Samer, you are waiting for the demo. Yes, it's coming right up.
I think we're ready. I think we just need to. I don't know how to showcase. Can we change sources?
So guys, let us know in the comments what are the types of use cases you're working on. Maybe you can mention a few things about the use case itself and make it a little bit more personal. So if you're working on an exciting use case you want to share with us, please let us know right away, or just comment with the use case you're doing. So I think there is a problem with the screen share. Let me try to fix that. Yep, here it is.
Now, great.
It's alive.
It's alive, yeah. So like I said, what we're showcasing right now is the SaaS solution. We also provide on-prem solutions, but so Konan is essentially a web portal. So I'm going to log in using my credentials. And what we're going to see first thing off the bat is all our deployments. So currently we have 3 deployments that are running. Let's forget about them for now. Let's actually create a new deployment. So first thing first, we're going to require a name for the deployment. So I'm going to actually deploy a house pricing model. We've created a model that predicts the house price given features. It's from a competition in Kaggle. We can also link the competition we've used the model with as well. So let's call it house pricing demo, for example. I'm going to deploy an XGBoost model. And finally, it's going to ask for container HT and container image URL. Konan, to be able to deploy your models, it requires models to be containerized, either in Docker, Podman, or whatever. So we know that, Abaza, can you mute your mic? I think it's...
Sure.
Yeah. Sure. So like I was saying, we know that data scientists are not that experienced with Docker. So what we've done is we've created a set of guides about how you'd go about to deploying this using our SDK. We created an SDK that automatically does all of this for you. So essentially what it boils down to is you write a piece of code that imports your model and the predict function, and that's it. You deploy it to Konan.
Shadi, can you explain very quickly what is a container?
It's like a mini virtual machine, but I think it's a bit out of scope of this demo because it's going to take a lot of time. But essentially,
just in 2 words, please.
Yeah, so it's like a mini virtual machine. Let's say. Okay. So after that, so let me put in the model that we've actually done. It's like I said, it's an XGBoost model. It's version 0.3.1. So if we press deploy, what's going to happen is Konan is going to pull this image and it's going to provision the necessary infrastructure for it to run, and it's going to run a couple of checks. It's going to check that the model is actually running, that there's nothing wrong with the model, and so on. And it's going to output, like you guys see, some logs about what's going on with this model. If you want to check out the logs and see if there are any errors for you to debug, you can do that. But thankfully there's no errors, there's nothing wrong in the logs, so we can just go to deployment. So this is actually the deployment view. And currently we have nothing because we've done nothing with this deployment yet. So what we would need to do, or what we logically need to do, is we need to connect with this deployment and run predictions. So we can do this in two ways. There's an easy way and there's the hard way. Let me start with the hard way. If you notice up top, there is a button called View API Documentation. If you press on it, Konan is automatically going to generate a Swagger document for your deployment. So these are RESTful endpoints that you can use and use to communicate with your model. So there's a lot of additional endpoints that Konan generates. So for example, it generates whatever you need for authentication, to verify that you're actually authorized to communicate with this model. Anything that has to do with the average response time, for example, of the model, the endpoint for prediction, the list of all predictions, list of dates, and so on. So there's a lot of different functionalities and endpoints. But probably the most important thing is the predict endpoint. If we press on it, we can actually try it live within the Swagger document. So if I press try it out, it's going to ask for the inputs. These are actually dummy inputs. Let me actually get something that would make sense. Again, like I said, these are features of homes. So for example, the overall quality of the home, the overall condition, the exterior quality. We're going to link the actual Kaggle competition later on. So if I press execute, this is going to send this input to the model and is going to output the response. So what you see in the output JSON, you're going to see the model return sales price, and the sales price is 126,000 or around that range. What Konan also does is it gives you the prediction UID. You would actually use that or store that in your database to be able to either cross-reference whatever you sent with what appears in Konan, or if you actually want to send feedback to Konan. So for example, if the model says that this house should be 126,000, you can send it feedback and say, no, this isn't 126. This was sold, for example, for 50. And you would use that, or Konan would use that to calculate either the accuracy or the error metric of your model on the fly. So yeah, this is the hard way of how you would communicate with the model. Let me show you the easy way. The easy way is you would use our SDK. So we've created an SDK that simplifies all of this process. If you're using Python, this is how it would look. You would define the input data that you need right here, and you would say, okay, SDK.predict. You give it the deployment UID, the identifier of it, and the input data. What it would return is the output and the prediction UID that I showed you guys in the Swagger document. So it's as simple as that. So you can imagine if you want to integrate with Konan within your infrastructure, you'd have this script embedded in for example, if you're using a streaming service, I don't want to see streaming service. If you're using a streaming pipeline, for example, like Kafka or whatever, you would input this right in, and whenever new inputs come in, you give it to the model and you get the output automatically. So yeah, this is how you'd connect with the model. So as you can see, it says we have one prediction done here. But yeah, this is the overview page. Let's go see the live monitoring page. In here, you'd actually see all the inputs and outputs of the model. You also see a line graph of the amount of requests being done per day. Let's take a look down here at the request that we did. So there's a log of when it was done, at what time, what model was used, the status codes, if it was successful or failed, who did it, that's me, the response time of Konan, and the model's response time. So this is like the overall response time and the model's response time. Don't get shocked that this is a bit too high. I'm gonna explain to you why. But yeah, if we press on the table, we can also see the inputs that we gave to Konan or to the model, and the outputs that the model output. So this is in a nutshell the live monitoring. I want to actually go. Abaza, you want to ask a question?
So should we have a few questions pending? Do you want to answer them now, or do you want to answer them at the end of the demo?
I think let's go through the demo. We can have everyone ask them, and we'll go after in the Q&A session. We can look at them.
Right, great. So guys, I'm keeping track of your questions. Don't worry. So just drop them, and I'm keeping track of them, and then we'll answer them at the end.
Yep. So yeah, let's go back to a deployment that actually has predictions in it, a lot of predictions in it. So this is the same model, but we've actually pre-populated it with different with data. So yeah, you can actually see these are all inputs that we've given to the model and outputs that we've given it to it as well. We've also given it feedback, and it calculated the mean absolute percentage error for us in the top right over here. But yeah, what I want to showcase right now is data statistics. So what this does is give you statistics on the data that is coming into your model. So think of it, if you've ever used pandas profiling, this is similar to it. So for example, if you have a feature called bedrooms, it's going to give you the minimum amount of bedrooms, the maximum, 1 and 5, the median, and so on. It also gives you how many, what percent of zeros is in it, and what percentage of missing or nulls is in this feature. It'll also give you a histogram of this feature as well, if you want to take a look at it. There's also basement condition. It detected that it's a categorical feature. There's 4 distinct values in it. Here's a histogram of it. CA has a count of 1,005, and so on. We also give out warnings for the percentage of missing values in a feature, and if they're high enough within a threshold. So for example, this feature has an 83% missing values, so yeah, you might want to look at it. So this is essentially data statistics, the statistics page.
Serving data statistics, not necessarily the training data, right?
It's not the data. This is what actually is coming into the model.
Yeah.
All right. Let's talk about data drift. So I think Abaza touched upon it a bit at the beginning, but let me explain it now a bit. So if you're training a model on a set of features, and each feature has a certain distribution, you would expect when going into production, the data that is coming into your model has the same distribution as what it had trained on. If they're different, you might get different results in your model in production. So what the data drift accomplishes is data drift page accomplishes is it gives you warnings on each feature if it's drifting or if it has abnormal values and so on. So let's take an example. So kitchen quality, it says here that there's a high infinity distance between training and serving. What this means is the model was trained on this feature using a certain distribution, but in production, kitchen quality has a different distribution. So this might be a problem that you might want to look into. And we also give it, the threshold is at 1%. We've gone way beyond this at 3.2. So you might want to take a look at these features and see what's going on. Column dropped. If your model was trained on a certain column and it did not receive it in production, we also flag this as well. If your model was trained on certain string values in training and it received something else in production, we also flag this as well. So we try to flag any discrepancies between the training data and the serving data. We also have a couple of features that are good. There's no issues with them, so thank God. So yeah, this is data drift in a nutshell as well. And there's also some additional fluff in Konan. You can view the logs of your model at any time. If you press model logs, you can view them. You can filter them at any point in time as well. I actually want to showcase challenger models right now. So let me go back. Let me go back to this model. So yeah, this deployment has 2 models in it. It has an XGBoost model and it has an SVR model. Both of these are running in parallel. But whenever you do any predictions to the deployment, you get the results of the XGBoost model. So what the challenger model does is it takes any inputs that the XGBoost model takes, and it automatically calculates any metrics that any of its metrics, and you can actually see its results or its performance at any time. So, for example, if I go, if I go to this model and switch it to live, you would actually see it would replace the live model, and you would see any metrics that it has calculated previously. And I can also add any number of challenger models, and they would actually run in parallel as well. And from here, you can actually see, for example, that SVR has a lower response time than XGBoost. So if your infrastructure requires time-sensitive response, maybe it's a good option to switch to SVR. You can also see the RAM and CPU usage of both models. So yeah, I think the last feature that we can showcase is the retraining. I'm going to go to another model for this. So at any time, if your model supports retraining, you can go to the retraining tab. You can press retrain model. You can select what you want the model to be after it's been retrained. If you want to be challenger or disabled, you can name it, for example, retrain model. And then when you press submit, it's going to retrain your model. I'm not going to do that now because it might take a couple of hours. But yeah, as you can see here, this we've retrained this demo model, and its name is now retrained model. If you go back to the overview, you see two models. There's the live model, which is the one we've requested the retraining to be done, and this is the output model, which is the retrain model, and it's now challenger. It runs in parallel with this one. So yeah, I think this is Konan in a nutshell. I think I skipped something, or should I go back?
I think this is good for now. Let's have a few questions. I just want to actually, on the data drift part, we were working with one of our clients on alternative credit scoring model, and they had this program that suddenly they did this program and they didn't tell us about it, and they were actually targeting like an age group that wasn't really, we didn't trade the data on before. So for example, let's say they were training from 55 to 65, for example. And this kind of segment, the model have not been trained on. So we didn't actually catch it, except when we were skeptical a little bit about the predictions of the model. And then this is if we had the data drift back then, we could have spotted it right away. So because Konan would give us an alert, guys, I have not seen this distribution before. I think there's something happening here. You might need to retrain. So and if we had Konan back then, we would have retrained right away, and we have been able to deploy very, very fast and didn't spend the few weeks that we had to take the model off production and retrain it and then redeploy it into production. So that said, let me, Shadi, ask you the first question. It's from Roland Hassan. So it's, I would guess that a newly introduced framework. So if Larissa, can you, yes, here it is.
Yeah, so I can read it. I would guess that a newly introduced framework would work fluently with Konan. Like now we have the Detectron 2 for object detection. What happens if we have Detectron 3? So essentially we're depending on Docker in that. So if you can put your model in Docker, which in 99% of the cases you can. So yeah, you can deploy it on Konan.
Great, thank you, Dr. Roland. We have also a question from Samer. Larissa, can you please put it on screen?
Okay, what is preparing and cleaning the data happens? Selecting features, you move directly to change the model. So yeah, like I mentioned, we're focusing on the deployment part. We believe that data scientists are actually more capable than any tool to be able to prepare, clean, and create models that are adequate. Abaza, can you mute? Yeah.
Sure. Sorry.
So yeah, we believe data scientists are the best when it comes to that. So we focus mainly on the post-deployment part. Thank you for your question.
So we have another question from Samer as well.
It's like AutoML. Okay, how to install Konan? Is it free to use by installing or any Conda env, or it need license? So right now it's a SaaS solution. So you can actually go in and try it out if you want for a 14-day trial. If you're interested in having it, you can contact us and we talk about if you want the SaaS solution, if you want on-prem solution, whatever you require.
And if you're part of the Zaka program, you can, of course, have access to Konan and use it for your capstone project and right away.
Yep. So there's another question. Can the model be used for computer? Oh, thank you. Thanks so much, Rudy. Yeah, so can the model be used for computer vision and NLP? Yes, but it depends. If your model requires GPU or GPU computations, you'd have to go contact us so we can provision that for you. If not, then it works just fine.
All right. I think these are the questions we have. We have also Zainab who says salut. Salut, Zainab. And yeah, so we've walked through a couple of very, very important features when it comes to actually putting your model out there and you want it to be adopted. So one of the main features was, of course, monitoring the requests. So you can look at how many requests are coming in and which ones actually were successful and which one failed. You can look at the logs also of the data, so the input data and the output data. You can look also at you can look at the data drift monitoring, which is extremely important. And this is, guys, I've heard from Devin one time. Devin is one of the very, one of the thought leaders in when it comes to technology and digital transformation in the US. And he once told us, data has a shelf life, and this is very true right now, because data is always changing with economic downturns, with everything that happens with the consumer behaviors, with we really have seen how data is changing in the past few years, especially. So data is always changing, and it might not change also from the market itself. It might change internally as well, since like I told you with the program from the consumer finance example, sometimes the company you're working with change the program, for example, change the customers they're targeting, change their policy, change their their promotion, the promotion type, and this will right away affect your model, and it will probably not produce the required impact. So if you have something like Konan under your belt and you have this type of technology, that drives your model, and you're able to very quickly adapt to the situation, retrain, do challenger models. Because also one of my favorite features actually is the challenger models at the end, because machine learning and data science is exploratory by nature. You're always experimenting with new things, with new stuff. So having that capability to really, gauge between two models with the same serving data, this is incredible, especially for data scientists who are always experimenting, who are always trying new things. And the changeover between the challenger model and the live model, to be able to do it with one press of a button, that's of course is a very handy feature for practicing data scientists. Yeah, so I think I summarized I think most of the features we went through. Guys, please, as Shadi told you, you can come to Konan.ai if you want to try it. And of course, if you're in the Zaka AI bootcamp, please let us know right away. And of course, we can give you access to be able to deploy your model for your capstone project. So that said, if there are no further questions, I think we can wrap it up. So Larissa, thank you so much.
Thank you so much for this talk.
us.
Yeah, I think Hiba just shared the link. You can go and check the app. And as Ahmed mentioned, if you need access and you're currently taking any of our programs or you're with us, please send us an email and we'll follow up with you. And I think we'll share the material and the recording for all the registered participants. You can go over it again, and you can also connect with Ahmed Shadi. And we also have here Hiba. I'm not sure if you want to go live, but she's also part of the team and she's supporting in the chat. So thank you so much. And just to wrap it up, please subscribe to our newsletter. We're always bringing such talks for you, and please suggest maybe any talk that you would like to hear. And that's it. Let's give a clap to Synapse Analytics team, and let's share maybe some feedback if you can. Great. That's it from my side. Thank you,
Great.
Sulaiman. Thank you, everyone.
Thank you, guys.
So much. Thank you, and see you very